Before we describe what a computer system bus is, let's describe what a computer system is. In very simple terms, a computer system is made up of three things. First, there is the CPU, or Central Processing Unit. It's like a railway's Grand Central Station, where decisions are made, and just about everything that wants to go anywhere must get routed through it at some point. Second, computers have lots of destinations for the data to go and stay so it can be used later, which we call its addressable memory. These are kind of like houses with physical addresses, where the pieces of data live when they're not being processed by the CPU. Third, there are devices that do stuff with data instead of just storing it, called input and output devices, so we can see or hear what's going on or interact with the data in some way. Okay, now that we have a basic idea of a computer system, here's what a system bus is. A system bus is kind of like all the train tracks that connect the CPU, the Grand Central Station, with the computer memory, the houses of addressable data, and with the neat devices that let us interact, like the mouse, keyboard, screen, and audio system. In early computer systems, all the data traveled across actual cables, which got pretty messy. Large bundles of wires were organized using bus bars, which is where the term bus comes from. Nowadays, most of those wires are typically gold-plated traces or tiny flat wires on the computer's motherboard, a large flat surface that all the electronic stuff gets mounted to. The most critical connection of any computer system is the system bus. Cables are still used in present-day computer systems, in particular to connect external devices. The most common type of connection is a universal serial bus, or USB, which you can probably recognize. Many peripheral devices, such as printers and scanners, use a USB connection. The system bus is a little more complicated than a single train track, but not too much. Think of it as 3 rails per track, kind of like mass transit trains use. That's because each track has to carry 3 different things: data, address, and control. The data are the actual digital pieces of information that need to get somewhere or do something. The address information describes where the data is located and where it needs to go during a particular operation. The control part is like the instructions, because data doesn't know what to do with itself. Think Lego Movie. So this manages the flow of address and data information. That includes which direction for the transfer of information and exactly how data needs to be routed through the computer system. Because of these 3 different types of information, the system bus actually consists of 3 buses. Think of the system bus like an internal mass transportation system inside your computer, busing data from place to place. Here's an example. Say you want to listen to a song which is on your disk drive. That song is stored as data on that device. Somehow, that data has to get to a device in your computer that knows how to turn it into sound, and then play that on your speakers. So we specify the address of the MP3 file on the disk and the address of the sound card using the address bus. We also use the control bus to tell the song on the disk how to talk to the sound card. Now, all the traffic can get underway on the data bus, allowing the song to play until it's over. All of this is managed by the Grand Central Station in the computer, the brains or CPU, but the system bus makes the actual transfers happen. We should explain a few more things to really get an idea of what a system bus is like. One thing about it is the bus width. That's the number of bits that a computer bus can transfer simultaneously. Another thing is the bus speed, which keeps the computer operations running smoothly and quickly. A very fast system bus is needed so that it doesn't slow down the computer's operations. In order to improve speed, several alternatives have been developed to the single system bus design shown earlier. Another big thing is that modern CPUs often have some memory right on the CPU chip itself, and that's called cache memory. This memory is really fast to access. When we talk about the bus for this memory, we call it the internal or backside bus to distinguish it from the main bus, which is often called the frontside bus or FSB. Technically speaking, the frontside bus is only one part of the system bus, but the terms are often used interchangeably. The speed of the frontside bus is an important measure of the performance of a computer. A very fast CPU and lots of main memory doesn't result in a very fast computer unless the front side bus is also very fast. So, when buying a computer, you'll often see the FSB speed reported as part of the technical specifications. This speed is reported in megahertz. A present-day CPU typically has a speed of several hundred megahertz, which is plenty to keep your computer running smoothly. The system bus connects the CPU, memory, and the input-output devices. It carries data, address, and control information. The speed of the system bus is an important part of the performance of a computer system, just like the speed of the CPU and the size of the memory.